comparar o método de fluxo de ar com o método de nasalância, que é a gravação com microfone do ar saindo da nariz e da boca. Então, vamos falar sobre esses dois métodos, comparar, e também vamos fazer uma demonstração com os audífonos. E vamos ver como que vai funcionar com esse método. E se dá tempo, já vamos começar a fazer visualização, senão isso vai ser o assunto que vai aparecer primeiro amanhã. Certo? Então, vamos primeiro falar sobre a lição de casa para hoje, que vai ser a última. Então, é muito específico dos objetivos que vocês têm. Então, agora é o quarto dia que a gente estamos conversando sobre dados de fluxo de ar, nasalidade, e a maioria de vocês já tem um objetivo e queremos que vocês pudessem sair do curso com já o próximo passo na sua pesquisa. Então, qualquer coisa que não ficou clara, qualquer coisa que é específica para os seus dados, a gente queria pedir para vocês prepararem perguntas sobre isso para uma discussão amanhã, tá? Então, pensar naquele próximo passo na sua pesquisa, que seja da seleção das palavras, do design do experimento, que seja visualização dos dados, ou mesmo escrever, interpretar os dados, os resultados, digamos. Próxima. E as últimas leituras são seção 4 daquele mesmo artigo de Whalen and McDonough e um artigo de Karen Rice, que é sobre ética em trabalho de campo. Então, só esses dois vão ser as últimas. Próxima. Então, próxima. Voltando para o nosso experimento de ontem, né? Então, a pergunta é se temos apêndice nasal, que seria prenasalização de uma consoante oral quando ela aparece depois de uma vogal fonêmica nasal em português brasileiro. Então, queremos comparar palavras de vários tipos e ver se a nasalidade, ou a nasalização mais do que a nasalidade, ela estende para qualquer tipo de consoante, ou se ela é restringida a alguns tipos de consoantes, e também se é específico das consoantes, ou também afeta as vogais, quer dizer, vogais fonêmicas orais depois de vogal nasal. Então, temos palavras de vários tipos, e no nosso primeiro exemplo tem a palavra lã, que é a vogal fonêmica nasal, e a gente foi colocando um adjetivo de 2 sílabas depois do substantivo lã, para criar a primeira série para comparar em cada categoria de palavra. Então, temos lã branca para consoante vozeada, lã preta para consoante desvozeada, lã linda para sonorante e lã azul para vogal, certo? Então, quais são os exemplos que vocês prepararam ontem, ou talvez hoje de manhã? Como que é?
Eu esqueci que tinha que fazer com vogal, então não fiz muito. Aí eu pensei, ok, tem com P, que é também pequeno, também pesado. Ontem preto, ontem pobre. Assim pequeno, assim pesado. Nenhum pequeno, nenhum pintado. Algum pequeno, algum pintado. Bem pequeno, bem pintado. Aí também bom, também bobo. Ontem bonito, ontem bobo. Pensei também em maçã, maçã pobre, maçã pendurada. Aí foram esses.
Muito bom, certo? A gente tem vários exemplos com P, né? Então, vamos começar com qualquer um daqueles exemplos. Você falou vários exemplos. É difícil de pensar em todos eles ao mesmo tempo. Então, vamos focar em qualquer um. Qualquer um. Qual que foi o primeiro? Uhum. Também pequeno. Então, também pequeno, aí a gente tem uma primeira... São 4 sílabas, né? A primeira palavra tem 2 sílabas e a segunda também tem 2. Então, também há pequeno e também pequeno. Então, são 5 sílabas. E a segunda palavra começa com P. Então, vamos ficar com aquela primeira palavra também e vamos procurar palavras de 3 sílabas que começam com B, L e vogal. Can you go to the next slide, Sunny? Eu vou escrever aqui. Por exemplo, também bonito, pode ser? Para a palavra que começa com B vozeada. Sonora, né? Também bonito. Aí L. Alguma palavra de 3 sílabas que começa com L. Can we turn... A gente pode ligar a câmera aqui? Não. It's the... não está ligada aqui, olha. Desculpa. Então, alguma palavra com L ou com vogal? Alguém tem uma ideia? Também? L, também? Também límpido. Oh, yeah, ok. É assim? Tem talvez uma confusão pequena com essa palavra. Vocês conseguem ver? É quase tem a estrutura que a gente está procurando. Tem uma vogal nasal depois, né? Então, a gente está procurando uma vogal oral depois. Na verdade, seria assim. Aham, é verdade. A gente tem esse mesmo problema aqui, ó. Então, seria ótimo no sentido de optimal, né? Se a gente tiver o mesmo ambiente fonológico. Por quê? Porque muitas vezes... deixa eu procurar um slide para mostrar. Porque já conversamos sobre isso no primeiro dia. Então, vamos olhar um exemplo concreto. Yeah, I'm looking for the slide. Hang on. vamos para a slide 39. Então, aqui temos um exemplo, né, que mostra que uma vogal entre uma consoante oral e nasal tem nasalidade gradual, subindo para a consoante, e vemos o padrão contrário quando temos consoante vogal, consoante nasal, vogal, consoante oral. E entre duas consoantes nasais, vemos um padrão diferente, né? É nasalidade que tem durante a duração toda da vogal. Então, a gente está fazendo mais ou menos a mesma coisa agora, só que estamos olhando a consoante. Então, seria melhor se a gente pudesse controlar também o ambiente que vem antes e depois. Às vezes não é possível. Às vezes o léxico da língua não deixa criar uma série de palavras que sejam perfeitas. Aí a gente faz o que a gente pode, né? E ainda mais difícil é que, com muitas línguas amazônicas, não temos dicionário como para o português, não temos um léxico tão grande para nós trabalhar, né? Então, às vezes, é um pouco mais complicado. Mas continuamos? Back to slide. Certo. Oh. Wait. What? Então, vamos ficar com límpido para agora, e aí vocês vão ver, ao gravar, se vai mudar. Alguma palavra que começa com A? Não precisa ser A, mas uma vogal oral. Também. Também aperto. Aberto. Então, aqui também aberto. Também azedo, por exemplo. Tem vários, né? Tem outra confusão que a gente está criando agora. Agora temos palavras de várias longura, como que fala? Length. De vários tamanhos, né? Então, estamos comparando, na primeira categoria, uma palavra de uma sílaba e duas, e no segundo exemplo, temos 2 sílabas e depois 3, né? O que mais? O mais sílaba que a gente vai ter também vai mudar o padrão do acento, né? Por exemplo, a gente tem azul com acento final e preta com acento inicial. A gente tem pequeno com acento na penúltima e límpido com acento primário na primeira, né? Então, são várias coisas que a gente também tem que pensar. É difícil, seriamente é uma atividade difícil. Mais um exemplo? Alguém quer compartilhar?
So I came up with the word hortelã. So it's hortelã baiana, hortelã paulista, baiana, paulista e hortelã libanesa. E hortelã americana.
Certo. Muito bom. Então, nesse exemplo do Nick, uma coisa boa desse exemplo é que tem um campo semântico que é igual para todas as palavras na categoria, né? Isso é uma boa coisa. As duas primeiras palavras têm, quer dizer, os adjetivos nas primeiras duas colunas tem baiana e paulista, 3 sílabas com o mesmo acento, né? Acento na segunda sílaba. E libanesa, americana, aí já muda, são 4 sílabas. Seria melhor que sejam todas de 4 ou todas de 3, mas o bom com esses dois exemplos de 4 sílabas, adjetivos de 4 sílabas, é que as duas palavras de 4 sílabas têm o mesmo acento, o mesmo padrão de acento, né? Libanesa, americana, penúltima. Certo.
Eu pensei num exemplo que talvez fosse interessante de testar. Dá de ouvir?
Eu estou ouvindo, pode falar.
Eu pensei que talvez fosse interessante testar uma palavra como jardim, por conta da diferença entre o A nasalizado e o I,
Certo.
porque, né, tem, em teoria, tem, né, diferença de nasalidade. Então, por exemplo, eu pensei em algo como jardim belo, jardim pode ser podre, algo assim.
Pode ser?
Foi o que eu pensei. Com L, né, com a lateral. Pode ser. Calma. Acho que eu me confundi.
Jardim limpo. Alguém ofereceu limpo, pode ser?
Pode ser jardim limpo. E jardim alto. Alto, não sei, algo que. São 2 sílabas, né? Pelo menos.
Jardim.
Alto.
Pode ser alto. Tipo que estivesse na cima do motel, alguma coisa assim.
Sim. Pode ser interessante olhar a diferença do A e do I, né?
Também.
Obrigada.
É certo, né? Comparar, se a gente for olhar o efeito de uma vogal nasal fonêmica em português, e a gente inclui só a nasal fonêmica an, na verdade, a gente está testando o efeito da vogal fonêmica an, não das vogais fonêmicas nasais do português, né? Então, é bom ter também exemplo como esse daqui da Rafaela, com I nasal. E tinha outros, tem também, em, an, in. No exemplo do Rian tinha não, né? Aon. Então, seria bom ter um exemplo, uma série com cada vogal nasal no inventário fonêmico.
Ali para equilibrar, para ficar a vogal local.
Jardim local. Ah, certo, para ti. Sim, porque tira a vogal nasal aqui. Local. Certo. Então, por causa da M, né? Então, a gente pode trocar alemã. Hortelã alemã. Sounds cool. Alemã. I need both hands to type a diacritic. Então, agora temos um adjetivo de 3 sílabas. A gente pode trocar libanesa para mais um adjetivo de 3 sílabas. Hortelã. Hortelã. Seria melhor, mas às vezes não faz assim muito sentido, né? Hortelã. Quais países que começam com L? Ou regiões? Aham. Com lavado. Uhum. Lavado ou lavada? É masculino? Hortelã cheiroso ou cheirosa? Cheiroso. Então é hortelã alemão. Não seria alemã, seria alemão? Tem uma série de palavras assim, que em francês também, que começa com vogal, porque a gente não costuma colocar o artigo, né? Libanês. É certo? Então, se for masculino, é assim ou tem com chapéu? É feminino? Lavada. Então, vamos começar a fazer algumas gravações com esse exemplo aqui? Dá para acrescentar mais, né? Na verdade, se a gente for fazer esse experimento real, de verdade, quantos exemplos que a gente vai incluir? Aqui temos 16 palavras, né? 4 por 4. Alguém lembra do número que a gente falou? Não? Será 200? Não, é muito alto. 50. 50 seria muito bom. Aí você vai repetindo, 4 vezes cada palavra, 200 palavras em total. Aí dá um experimento de mais ou menos meia hora, 45 minutos. Certo. Então, próxima. Na verdade, talvez a gente deixe aí para poder ler ao mesmo tempo. Vamos deixar ali. Are we ready to record, Matt? Okay. Who wants to start? Quem que quer fazer gravação das palavras? Everyone? 1, 2, 3, 4, 5, 6. Certo. Uma coisa. Mais umas palavras? Vamos lá. And go to different ends of the room, maybe, because if they're next to each other, it... Oh, okay. Uhum. Uhum. Como que? Ah, quem bebeu? Aham. Quem pegou? Quem levou? Quem achou? Certo? É, só que bebeu temos 3 sílabas. Tem mais um. Banhou, talvez. Quem banhou? Ah, mas aí tem N. Aí tem nasal. Quem? Bateu? Bateu também tem 3. 2 sílabas. Abaixou também tem 3. Certo? Quem bebe, quem pega, quem leva, quem acha. Muito bom. Muito bom esse exemplo. Vocês estão começando a entender super bem o objetivo, né? Trem? Uhum. Do we want to control what? Então, num experimento de verdade, seria melhor se a gente fosse controlar o tamanho de cada palavra, né? Mas, se não conseguir controlar, seria balancear. Quer dizer, ter o mesmo número de palavras que tem uma sílaba, mesmo número de palavras que tem 2 sílabas, mesmo número de palavras que tem 3 sílabas. Então, aqui a gente tem 2 palavras com uma sílaba, lã, quem. Tem também e jardim, com 2 sílabas. E aí tem hortelã. Então, a gente acrescentaria mais uma palavra que tem 3 palavras, por exemplo. Uhum.
This is a case where I think it's possible to avoid balancing altogether. There have to be enough monosyllabic or disyllabic words, especially because we don't need that many. So I would advise against balancing in a case like this. You should be able to control for everything in theory.
Talvez no português, né? Mas numa língua indígena talvez seria mais difícil se tiver um léxico muito mais pequeno. Mas é verdade que em português eu acho que a gente consegue fazer com 1 e 2 para todas as palavras, né? E na segunda palavra dos exemplos, também temos 2 sílabas, 2 sílabas, 3, 2, 2. Então, seria balancear também o número de palavras com 3 sílabas no segundo morfema. Faz sentido? Tá. Então, eu acho que estamos prontos para começar a gravar.
Não é problema termos só a vogal A nas últimas caixinhas? Aberto, azul, alemã, alto, acha. Temos só A, vogal A.
Aqui, então, é verdade, a gente poderia incluir várias vogais, só que aí a gente precisaria fazer mais umas colunas, porque o B, P e ele são todos o mesmo segmento, né? Para toda a coluna. Então, aqui eu acho que não tem muito problema em ficar com a inicial para a segunda palavra da última coluna. É mais importante incluir vogais nasais distintas do que vogais orais distintas aqui. Se a gente for incluir mais vogais orais, aí precisaria acrescentar mais uma coluna. Ok, vamos lá? Quem que vai começar? Duas pessoas. Vai, Davidson. Mas são duas pessoas que vão fazer ao mesmo tempo. Uhum. Ah. Is it random.org, Matt?
Random.org is good, yeah. And you can just put the list on the screen in theory, and
Uhum.
you can read off of it.
Eu estou passando pelo random.org.
So people should divide among the two computers. There's 1, 2, 3, 4,
Wait,
5,
is
6,
it?
7 of these. Random.org, yeah. Go to the very top.
Oh, list randomizer?
Or there, yeah, list randomizer. So four people should pick one computer, 4 people should pick the other one. Go to the computer, don't go to me. So there's another one over there. No special login needed. Just go. This is here. So we'll be going and looking at the computers and making sure that things are set up properly. So before diving in, we'll want to check what the command is that comes up on your command line. The physical equipment is set
I'm going to make 2 or 3 lists. Hortelã alemã.
standing by the computer. Okay. This side, this side, this side.
E mais uma.
We have 3, 1, 3. I suppose now that thinking about this now, let's practice good recruitment of participants, balancing participants. Cynthia, you go over there.
Então, temos
Go over there.
3 versões das palavras.
Sometimes we do need to make sure that we're getting. This is something we can mention. It's a good idea to. When you're. All right. Sorry, Zoom. I was distributing the laptop groups a bit more evenly and making the point that we didn't mention yesterday, but when you are recruiting people, it's a good idea to try to get both men and women. So we're doing that in practice for each computer separately, in case something should go wrong with the computer. There's a practical reason too, though, to maybe reconsider that, which is that the mask sizing might or might not work for everyone. For all of the men, the large mask should work. I was going around and looking at people's faces earlier. Now you know what I was doing. I'm pretty sure that the large mask with extra pressing will work for everyone, but we can plug in the small mask at the we're talking to the Zoom again. Okay. In theory, we have 20 words here. And we have how many conditions? 4. We also have different words that are providing the nasal vowel, right? But maybe it's not necessary to think of them as conditions per se, right? So we have 4 conditions. And we have 20 words. This would imply we've got 5 words per condition?
I think we do, yeah.
Yeah. So we have 5 words, we have phrases. We have 5 phrases per condition right now. So 5 types, as we said yesterday. And in theory, we want a certain number of tokens per condition. I said the rule of thumb is about 20 as a minimum. So that means if we read each word 4 times, we would be okay. So just to practice thoroughly, during the recording, we could repeat the word 4 times, or the phrase, excuse me, 4 times.
Or randomize the list 4 times.
Or you could go through the list 4 times. I do find that for this, it's probably fine to go through the list once and just repeat. We don't need to be that precise. This is just a toy study. But yeah, in theory, you could get 4 randomized copies of the list and then go through those separately instead. But yeah, let's read 4 times. Does this group have a...
It can take a really long time.
Not really. It's 20 items. And also, I don't think we need well, okay, here's the other thing. I don't think we technically need everyone to read every item. So,
That's what I mean. But
yeah, we could...
might as well have everyone go through the list once.
I mean, this is more for the recording experience than for getting an actual data set. So, I mean, if we wanted an actual data set, we could actually create one, technically speaking. But, I mean, I don't know. Do people want a data set? Maybe it wouldn't hurt. Let me think, though. Phrases read 4 times, 20 straight through. Each one of those would take, once people get up to speed, about 1 to 2 minutes, optimistically 1 a piece. So it could take 20 minutes a person if we did,
Take at least an hour and a half.
or if we did 3 at each one, an hour. But, so yeah, that would be a little much.
Okay, let's just do
We can safely,
the first 5 words of each, for each person.
oh, and then like 6 through 10, and then 11 through 12, and then, okay, yeah. So to be clear about the arrangement, after 5 words approximately, we should change the person who's recording. Instead of having everyone go through the whole list, that would take a very long time. So, okay, to review. Everyone does 5 words. Everyone says phrases, excuse me. Everyone will do 5 phrases. Everyone will repeat them 4 times. You trade off positions as you go through the list. This group will have 1 person doing it twice.
So why don't you do the second list, and we'll
Yep.
do the first list.
Yep. Do you have a photo of the first list?
It's right here.
Okay, good. So both groups have a photo. Both groups have the physical setup. Both groups know the format of the recording. So now let's record R0. I'll still talk to the Zoom for this because this is important. So the 0, we need a 0 recording. Everyone put your masks down. Put them down. Other way. Facing down onto the table. Down. Now back up. Away from the mask. The person from the computer has to stay at the computer, but move a little bit away from the mask. We don't want to be too close to it. We don't want to breathe on it. The person who is running the computer has to edit the command first to put things in the right place. So push the up arrow. Don't push enter yet, but this will recover the previous command. Push the up arrow. That's all you do. You push the up arrow once. So this will bring you the command. You need to edit this now. We're going to make a fake, I think we're going to make a fake researcher name so that it's just the same value throughout. What's a very general Brazilian name? João, okay, J. João, we need another name. João Oliveira Souza, J-O-S. Okay, our researcher is named J-O-S, João Oliveira Souza. Okay. So there will be the researcher flag, all right? I want everyone to change the researcher flag so that it reads JOS. To do this, you'll have to use the arrows to navigate through the command. You'll get there eventually, and you can delete, it'll say MDF, that's me, and you can change to JOS. And so you've changed to JOS? Okay. We have to be very particular about the format. Looks good, JOS. The lang is, of course, POR. And we changed the language to POR. I'm assuming that's the ISO code for Portuguese. OS. JOS.
Aí tem language. Is it language?
POR for language. Yeah. I don't know what the ISO code actually is, but so we're missing some things in the command here. Yeah, no, let's just start again from a fresh one. Okay, so go over, and we want AC, we want the researcher to be JOS, João Oliveira de Souza. The language, if we arrow over, will be POR. Let's let him do the next one. And we can now change the speaker. We can change the speaker to be appropriate to whoever's going to talk. So you need to put, whoever will actually be talking, put 3 of your initials in. I would be MDF, Matthew Donald Faytak. Right, so take your pick, use 3 initials that work for you if you have more than 3 names. Whoever's going first will need your initials. Oh, but I told everyone to move away, right. Okay, that's still, it applies when we make the recording. So I thought we were gonna start and then I forgot about the commands. Okay, now if we have all of those values set, we need to change the item that we're recording to a special item. It needs to read _0_ in the quotes. Myriam, you know what this looks like, so you can help there. _0_ inside of the quotes.
Like that, right?
No, the word 0. The word 0. ZERO. _ZERO_. Excuse me. So this refers to the type of the recording, not the number. So once everyone has it entered in, a 0 recording is supposed to record nothing. That's the entire point. If we're not immediately near the mask and we're not breathing hard on it or something like that, and the command is properly formatted, we can hit enter and watch the data collection run. Is it going? So if it's gone for a couple of seconds, you can stop. You press Control-C, like you're copy pasting. And then it should have stopped. Yep, that looks like nothing. Let me see what kind of nothing it looks like. Yeah, you're good. Okay. So the 0 recording won't look like literally nothing. That would just be a flat line. If you see a flat line that doesn't have any variation, that's actually a problem. It means that there's no data being brought in. We expect the sensors to fluctuate a little bit over time. So we should expect to see a jagged line that doesn't move very much in each of the airflow channels. We should see that here too. Yep, that looks good. It's not literally nothing, but it's close to nothing. So if we look at the recording that we have pulled up in the window now, we might notice nothing was happening, but the airflow is not at 0. Like the line is not next to the number 0 on the scale. Can we see that? This one is centered at about 160 for oral. This one's about 500 for nasal. The other devices' values will be different. So this is why it's important if we want to compare data across devices, as we often will want to subtract the sort of default activity from the recording. So in this case, later on, if we need to calibrate, if we're comparing just our own recordings, we don't necessarily have to do this. If we're comparing with anyone else's, or we want to know if 0 really is 0, then we do actually have to subtract these numbers out of the numbers that we get from the airflow. There's various ways to do this. We happen to have not produced an easy way of doing it in like Prot or something, but it's possible that we'll produce one and send it to people. I have to think about it. And we both have zeros. Okay, so everyone can, this is also a good teachable moment. What you do when you're finished inspecting your recording, as we always should inspect our recordings, when you've inspected it and confirmed that it looks good, you simply close the window. You X out. This will then bring you back to the command line. At the command line, you will no longer have a command running. But, as we discussed, you just push the up arrow, and it returns you the command again. But now, all of your values are set, and you may change the item that you're recording to the first item on your list. So let's all do that. Let's change the item to the first item on our list of stimuli. The speaker should sit down and get ready. Already seated, already possibly ready. And make sure we are holding this in the right direction. Be careful not to entrap the cable with your hand underneath here. That will cause errors. So generally hold like this, not to grab the cable underneath. Okay. And well, if you change to the first item on the list, you sort of know how to do this. So you'll want to check for fit. So you'll want to apply the mask before you make a recording and see how it fits. So go ahead. Well, you want to see how it fits her first. Other way. Other way. Voila. Yes. And now you want to push on. You can take the glasses off if you need to. I've not ever needed to, but some people do. And then we want to see where it hits on the nose. Should press here. Should press here. And we need to check her chin. There's a lot of space. I can turn the mic off now, I think, because we're just talking in the room.
tá, agora tá. Tá babado.
Cíntia.
Ah, sim.
Agora sim. Então, Davidson passa a palavra.
Pra
Eu
cá.
passo a falante.
Agora vem a Cíntia pro balcão.
Researcher.
A contribuinte.
Certo, então agora vamos mudar para as iniciais do Davidson.
Meus D, C, R. Não, põe D, C, R.
Tem algum lugar que não pode passar o pano também.
Passa por
Tudo mesmo.
para tudo, né?
Ela tá limpando tudo aqui.
Não, porque às vezes tem, sei lá, não pode passar no dispositivo, não pode. Não pode
Em qualquer lugar que
Só da cama que boa, mano.
ter bactéria, né?
Aham, sim.
Acho animal.
Eu já tava sem bosta.
I don't know what causes it exactly, but we do find that it happens more when people have to push harder on the mask. I'm not sure precisely why.
Qual é o?
Tu vai ler do
Documentar.
11 até.
Do 11 até o 15. Hortelã lavado.
Qual que é agora?
Agora é hortelã lavada.
Marina?
Aí é só apertar Enter pra começar a gravar.
Aí quando a gente terminar, tu Ctrl C.
Hortelã lavada, né? Hortelã lavada, hortelã lavada, hortelã lavada, hortelã lavada. Elas nasalizam. Fecha. Agora é quem acha.
Quem acham quatro vezes a palavra? Eles fazem quatro ações diferentes ou eles fazem uma espécie de molde?
É igual. Espera aí.
Quem acha? Quem acha? Quem acha? Quem acha?
Esse é o arquivo, né?
Quem acha?
É
Então as quatro repetições estão
numa arquivo só.
no arquivo só.
A próxima é. Mano, tu tirou minha foto pra eu mandar pra Marina? Vai me fotografar.
Eu disse pra ela que isso aqui
Quem
é só
acha?
paciente.
Lã branca, né? Agora. Lã branca. Lã branca, lã branca, lã branca, lã branca.
Fairly different between the two channels. I mean, there's more nasal flow in the world.
Será que
I
eu
mean, they
conto
track
com
each
você?
other so much, so it's
Quer que eu conte com você?
Tá. Agora o item é também pequeno.
like, and it's not people's fault, it's the mask's fault.
Também pequeno, também pequeno, também pequeno, também pequeno. Tu viu que o E dela não é aberto, não é pequeno. O E é fechado. Acho que é o último, né, agora? Hortelã alemã. Hortelã alemã, hortelã alemã, hortelã alemã, hortelã alemã. Ih, na última já.
Fechando ou tá levando?
Só fechar.
Só fecha.
Vai, minha vez. Yeah, you do your thing. The larger mark is better.
Hortelã alemã, hortelã alemã, hortelã alemã, hortelã alemã. Ih, ela não quer.
Também não.
If you let it dry for a second, you may as well try
Ela é alemã, mano.
and see how it fits.
Os alemães são impossíveis.
Quer ser paulista?
Sometimes for it to be a bit
Faz a francesa, mano.
It just
Hortelã alemão. Hortelã alemão. Hortelã alemão. Hortelã alemão. What happened?
Às vezes acontece. É assim.
Mas só tá apertando bem essa coisa.
Acho que sim.
Já que não cabe.
Hortelã alemão. Hortelã alemão. Hortelã alemão. Hortelã alemão.
Ai, vai.
Acontece.
É a
3
Bahia.
vezes. É a
Às
uma.
vezes, quando acontece muito, ou muitas vezes de seguida,
Reinicia?
eu reinicio. Não sei se ajuda, realmente não sei.
Quem vai ser o researcher e quem vai ser o
A
falante? Tu vai ser o
configuração do
researcher.
aparelho.
Tu vai ser a falante.
Porque a primeira coisa que você faz é ligar o aparelho, então eu volto a ligar. A comanda para ligar. Então, vamos ver se ela fecha bem na sua boca. E se não, a gente troca para mais pequena.
Tu limpas? Faz todo o Não, faz todo o protocolo, mano.
Falando que higieniza mais.
É um caso especial.
Sim, mas quero que o celular. Aquele é o meu.
Ah, quer dizer que dele e tirar foto.
Tu és, mano.
Vai ficar um cheirinho de bebê.
Se eu for fazer um experimento desses no campo, sozinha, quer dizer, agora eu tenho o meu equipe e eles me ajudam, né? Mas é muita coisa para controlar na hora de gravar. Então, às vezes eu pago uma diária para um dos meus amigos indígenas para ele me ajudar, né? Então ele sim lavaria a máscara, por exemplo.
Sim.
Ok. A gente parou em qual? Hortelã alemã?
Não, acho que foi
Foi
na.
hortelã. Deu problema. Então.
Hortelã alemã, foi. Aí.
É, o meu é C-O-I. Aqui, ó. Não, aqui, speaker. C-O-I. A gente vai começar com também límpido.
Também.
Límpido.
Belém também.
Belém também.
Uhum. Já.
Também límpido, também límpido, também límpido, também límpido. Não ficou tão...
Então, você vê, né, que tem menos ar, tipo, a altura das linhas é menos, quer dizer que está saindo um pouco o ar. Você quer tentar, ou com a máscara pequena, ou colocando uma toalhinha embaixo para fechar. Você que sabe.
Vai trocar pra pequena?
A gente pode tentar trocar, então, né?
Então, meio parecido também, né?
A máscara foi muito grande?
Para vocês verem a diferença, né?
Uhum.
Como seria a troca?
Como é a troca? Se você precisar, por exemplo, no campo, trocar pra uma máscara menor. Como é o processo?
A gente pode trocar. Como que você quer fazer?
A gente pode trocar, mas...
Ah, tá.
Não, só pra gente ver o que fazendo o processo.
É só tirar.
A gente todo.
Só tirar. Vamos ver, às vezes a pequena é muito pequena. Já vamos ver.
Precisa higienizar essa de novo?
Você pode, eu acho que ninguém usou, mas igual assim, pode limpar.
Também límpido, né?
Segura, não.
Também límpido, também límpido, também límpido, também límpido. Ah, dá pra ver, né, a diferença. O sinal tá muito mais forte. Agora
Ah, mas espera aí. Olha,
Achei muito igual.
é muito igual.
Where's that?
Eu também tenho esse problema. Quer dizer,
Os dois canais.
how do I take a screenshot of this? Alguém
So what do
sabe
we see?
fazer shot aqui?
Oh, is this a leakage? This is a leakage.
We have a merge.
Yeah, that's a pretty clear merger. Usually the solution is to just push 10% harder.
We can try that. We can try it, but if not, we'll go back to the other mask.
I find that the small mask results in
A
mergers
gente
a
não tinha
lot more.
exemplo desse para colocar no slide.
You're welcome.
The reason you get more mergers with the small mask sometimes is that there's less room for the nose in the top box, and so people are able to push in less, and so this doesn't make it to the lip at all. So you do have to be careful that you're pushing so that this touches the lip. It'll feel like your nose is not going to fit, but you should make sure that you are pushing enough that it touches your upper lip.
Can I close this?
Yeah, you can close it.
It will be very snug. It will be very tight. But you will be able to talk.
também límpido, também límpido, também límpido, também límpido.
Agora parece que sim.
Yes, that's better. Does anyone see what I'm looking at to instantly say that they're better? There was an oral stop in this phrase, right? Just a plosive, like ka or pa, right? Where can I see that? The big vertical lines in the oral airflow are where the stops are released. The bursts. So if I look at a burst and I don't see it in the nasal flow, that means that the signals are not merged. So they're very different. That's good.
And then there's an inhale through the nose
Oh, yeah.
and an exhale through the nose that we don't see through the mouth.
Everyone's saying
Acho que é celular para desbloquear.
looks good as well.
A gente tá na primeira lista, né?
É,
Também aberto.
também aberto.
Tem que criar 9 estamos em 20 aí vai estando em 20.
Também aberto, também aberto, também aberto, também aberto.
Esse negócio chato aí, só mais que no excesso, na maioria das vezes.
Where's the line?
I don't know.
Where's the line?
Sometimes this window can look strange. Sometimes you don't see the line.
Okay.
It's not at 0, which is the reason. Basically, the baseline is so high.
If the person doesn't inhale
You might not
through
see
that
it.
channel, sometimes you just don't see the zero line at all.
Or inhales before the recording starts.
Okay. What's the next?
Quem bebe é quem beba. Quem é quem bebe ou quem
Quem
beba?
bebe, né?
Acho que é quem
Spikes
bebe.
in the oral channel, and we know that plosives at their release when they go, etc., they cannot be nasal. And so we should only, well, usually not, but we should only
Quem
see
bebe, quem bebe,
spike
quem
in the
bebe,
oral channel.
quem bebe.
And we can look and we can see below it that nothing happens in the channel.
Ele tá falando quando a gente fala de explosivo, né? Que
Outra
Dá pra ver a única vogal nasal, né? Do fluxo de ar nasal. Tá aqui. Hein.
It's okay if you guys only go to 15, like 5 each.
outra lança.
Lanzo.
that some people prefer to hold the mask up between trials because then they don't have to reposition it. But other people prefer to take it off. So it just depends on the person.
Okay.
Lã azul, lã azul, lã azul, lã azul.
You at the end. That looks a little bit
Pra quem leva?
close to being synchronized.
É a última?
I don't know if
Ah, tá.
última.
É a última agora.
Looks a little merged.
E vamos para a Tex.
Não, é quem leva.
Você que fez todos os tech screens.
And if you don't read it, but if you want to move on, it's also okay. Yeah.
Quem leva, quem leva, quem leva, quem leva.
Certo.
Aí acabou, a gente limpa a máscara.
Então já terminamos?
Consegue abrir aqui.
Vocês estão travando ainda?
I have one more person. We have a more complicated side.
Peraí só.
I was saying how probably Brazilians are probably one of the more complicated groups of people to work with in terms of getting the masks to fit. Everyone's a bit crazy. Everyone has differently shaped heads to varying reasons.
It's okay.
It's a complicated country.
Não tem curso, mas já.
So if there's a Brazilian who looks like me, the large mask fits me in the front.
Absolutamente nada. Tipo, eu tô na frente do computador e eu não consigo ler o que é
But then for everybody else,
A gente vai conseguir chegar no tratamento quantitativo desses dados.
Quantitativo
não.
não.
É quem tem.
Mas, por quê? Porque, vamos conversar sobre isso amanhã, porque para chegar a fazer isso, você precisa aprender estatística, programação, que a gente não consegue cobrir numa aula de 5 dias. Mas se vocês tiverem interesse em fazer isso, aí a gente continua conversando depois da aula. Mas o que vamos fazer amanhã é pelo menos aprender a visualizar bem os dados para fazer análise qualitativa, pelo menos.
Prático mesmo.
Yeah, it's okay.
Fazer aquelas medições, transformar em prática.
You're gonna have to say quem levou. Ok?
Eu vi naquele artigo que você mandou, que era mais curto, sobre a harmonia nasal.
Sobre o piaroano,
Isso, aí eu usava o R, né, para fazer o tratamento quantitativo.
é muito, mas é um modelo estatístico bastante complicado. O problema com a harmonia nasal, com os dados de produção, é que para fazer um modelo estatístico que toma em conta
and you have to check under the chin especially.
a duração, né, o tempo que muda
So it's
de
actually quite hard to have
ponto
this adapted.
dos
If it
dados
fits
para
well up
outro,
in this area,
esses
you're not
modelos
very likely to have
estatísticos
gaps.
são os mais complicados.
But yeah,
Por quê?
that's fine.
That looks good. Fine.
Porque os
It's very
modelos
snug.
estatísticos normalmente têm uma assumption
So you should try it
que é que cada dado que você tem é independente
Okay.
do outro.
If it doesn't have a gap,
Mas,
if it has a gap
tipo,
here, it's okay, but it should be there. Like,
dois
So
pontos
there's what's
na
not
duração de uma
what's less obvious
vogal
is
não
there's a
são
lot of
independentes,
material
né?
inside
A
of the edge of the mask.
posição
So it
dos
looks
seus
like there's a trim
articuladores
gap
dentro da
very
boca,
top isn't a gap.
num segundo,
Okay.
depende
Because
de
inside
onde
it's
eles
usually
estavam
touching the nose.
o segundo anterior,
Just
né?
inside.
Então não é
With the
independente.
chin, you can
Então,
tell right away.
por isso, precisa fazer
because of the
um
shape.
modelo
With the nose is
estatístico
hard.
bem mais complicado para resolver esse problema.
Não pode não ter porque o material
Modelagem estatística.
Queda de Diniz.
O Ronaldo trabalha muito no
Eu gostei muito desse artigo quando fala, principalmente, sobre a pré-nasalização, que não é muito descrita ainda, né, nessas línguas. E essa pré-nasalização, ela seria só em relação à harmonia nasal, ou seria, porque eu não consegui ver se era de forma clara, ou se era de forma mais geral?
Não sei. Não sei. Mas ninguém tinha descrito, né? Então, mesmo que não for descrito, eu já não posso acreditar se alguém possa me falar que não existe. Entendeu? Então, esse tipo de prenasalização é muito pouco descrito, na verdade.
Eu vi.
Falando
Então.
sobre algo um pouco descrito, eu estava conversando com a paciente sobre isso. Aí ela comentou que você realmente falou que em onde você estuda tem conteúdo geminado, né?
No meu? Sim.
Pois é, aí eu queria saber, porque em Palmaria aparentemente também teria,
Ah, é?
segundo as primeiras descrições. Aí as mais recentes fizeram e um comenta muito sobre geminação, né? Sobre consoante alongada. E que por isso não. E ela não tem contrastivo, não tem valor contrastivo, segundo essa análise mais recente. E aí ele disse que tipo, o pé seria iâmbico, só que ele é insensível a peso. Só que.
É a mesma coisa em Panamá.
Sério? Deixa eu vou dar mais uma olhada. Só que aí, olha só. O Everett vai dizer que ela é insensível ao pé porque não tem o alongamento não é contrastivo. Mas aparentemente tem sim um valor fonológico de alongamento. Então já fica. Teria que fazer uma reanálise da análise dele. E eu queria saber contigo assim, será que consoante geminada tem valor? Então, tipo, tem?
Não atrai.
Contribui em peso?
Não.
Não, né?
Não. Em Panará é complicado porque tem contraste de consoante curta e longa e de vogal curta e longa. Então, o contraste existe em todos os ambientes, mas tem um ambiente onde as vogais curtas viram longas. Então, nesse ambiente específico, são alofones. Então, vira ainda mais confuso entender onde contrasta e onde não. Que é um tipo de fenômeno que a gente chama de contrast neutralization. Que existe um contraste, mas em alguns ambientes fonológicos eles são merged, neutralizados, exatamente. Que vira a coisa ainda mais complicada. Mas eu tenho uma apresentação sobre isso. Deixa eu ver.
Em Palmaria, aparentemente, a geminação ela é causada pelo acento. Então, tipo, o acento recai numa sílaba, a vogal ela fica um pouco alongada foneticamente e a consoante da sílaba seguinte ela gemina. Então, quando troca o acento, aí acontece com a outra sílaba.
Isso é mais um padrão, tipo, iâmbico mesmo, esperado do padrão iâmbico. Bem interessante, eu não sabia que tinha mais padrões com consoante geminada.
Mas no caso, o consoante geminado não contribui em todas as línguas do mundo? Pela peso?
É porque ele não coloca peso para consoante, né? Não, é no livro do Reis, na teoria dele, né? As consoantes, elas não
contribuem em peso.
Que a nora mesmo vem da vogal, né?
Amor é a vogal. Amor é legal. O que foi?
Yeah, we're done. There we go. We're just talking about some other stuff now. Aqui, ó. Tem uma análise da duração vocálica. E das geminadas também. Mas agora tem mais uma, parece. Fake minimal pairs. Então, por exemplo, SOT e SOTI, que parece um minimal pair, mas o I aqui não é fonêmico. Ele é acrescentado depois de uma coda em final de palavra. E você consegue ver isso colocando os morfemas numa estrutura complexa. Por exemplo, sopio, quer dizer nada, não tem nada. E sopio quer dizer não tem fox, é raposa. Uhum.
It's actually pretty fun when it works. Yeah. Some people it works really easily for. Other people.
E é nessa posição onde
também
você acrescenta a vogal epitética no final, que tem alongamento da vogal curta. Mas, olha, aqui não tem vogal longa, só pio. Virgínia nada.
Interessante.
A descrição fonológica é, na verdade, bem complicada.
The next one is the last one? Yeah, it's the last one. Yeah. Judging out.
Yeah. We finished.
Are they finished over there?
They're almost finished.
Almost.
Ready?
Almost good.
Judging out. Yeah, it's the last one. Judging out.
A gente podia não terminar na hora do intervalo.
Talvez, né? A gente volta depois. Should we just take a break when we're done recording that?
Sure. Although we might end up having like an extra 15 minutes before the coffee even comes out. So there's got to be some small, like the dinner chunk is doable in 15 minutes.
Yeah, that would be good to do.
We should probably do that.
Okay.
Oh yeah, someone has to repeat like you. Tu tem que repetir. Yeah. Porque a gente só tem que repetir.
I'm gonna move the slides over, Matt.
Agora a gente pode voltar uma foto. Eu não consegui. E vão te pedindo.
Deixa eu ver aí. Espera um segundo. A gente vai olhando juntos.
Tem mais foto.
Okay, they're in the right slot now.
Uma máquina. Deixa eu limpar uma pequena.
Oh yeah.
Ah, ele usou aqui.
Aí quando o King nada disso. Essa é uma frase que eu pedi pro Dr. Mari, a gente já viu. Essa semana agora. Um dia sobre você. Então aqui eu falo estrela 3 vezes. Aqui eu falo a estrela.
Sim. Agora é. Quem acha?
Uma frase assim.
Tem que encaixar mais.
Aquele método que a gente usa para poder colocar os dados quando coloca uma palavra, uma frase, coloca a palavra dentro.
A frase quadro.
Just a little, yeah.
Não sei. Carrier sentence. Como que você traduz?
Não sei, eu coloquei carrier sentence. Então eu queria que ele fizesse isso. Então, tipo, eu de estrela 3 vezes. Então o estrela seria o alvo, né? A coisa analisar. Só que em Palmari não dá pra fazer isso. Porque em Palmari, quando eu quero analisar, tem um mês. Ele vai ficar no final do esqueci.
Pois mas aí você pode falar, pode fazer mais uma estrutura. Aqui, assim,
Oh, the disc.
That'll happen now. Por exemplo, ele pode falar assim.
No, we also have a bunch of replacements in case the mesh breaks. Yeah.
poderia tentar mais uma estrutura.
Yeah, if you need to pull the box out, I can
Muita,
also.
muita estrela no seu.
minimizing the left
Yeah, because the box in the mask.
Oh, you have to push from the inside.
Não, talvez não funcionaria para o eu vejo.
But we could
Depende
finish.
do tipo de palavra. Se for todos os caixões, seria mais fácil.
Oh, I know, I said you could stop. Okay, it's fine. And this is upside down.
Oh.
E as duas frases.
Anyway, yeah, we should probably go to the slides for a second and then take a break. No, it's fine. There were only 3 of you, so 5 apiece.
Ele falou que a gente pode parar.
É,
could see where the files were being saved. So, okay, we're all finished up now.
Mas no caso, para fazer coleta dos dados nasais,
So we can talk data handling now. I think we're all finished.
Yeah, do you want to do it?
I figure since I'm going to talk about nasal and second break, you can do this. I do want to get a quick word in first about where the files actually went that we just recorded, but that segues. If that's okay. There's a whole slide about your file naming conventions anyway, so I figured we should talk about that. Okay, where's the microphone? Hello, hello. Okay, a quick few slides before we go on break. One note that's not on the slides, by the way, for everyone. You may be wondering where the files we just recorded went. Where were the files saved? The script that we were running automatically saves the files. But where were they? So the files are saved actually in a predictable location. If the script is set up correctly, which it is on both of the computers, you would know exactly where to look. There's a particular folder that they save to, and well, inside of that folder, there's a folder that will be labeled POR for the language, and then inside of that folder, there will be a researcher. I think I might have it backwards, but they're nested in some way like this. Inside of that, there will be a researcher name, JOS, and then you go into that folder, and then inside of that, there should be 3 or 4 different folders for different speakers. And then inside of those, there will be a folder indicating what the date was. So today, the 21st, 22nd? 21st. And then you enter that, and finally, having accessed all of those layers, the files are inside. The names of the files were automatically created as well. They contain all the information that you might need to know. Everything I just mentioned, all of the names, the name of the language, and the item that was recorded, in addition to a token number. So if you only recorded one token of an item, it will show up as 0 at the end, because Python, the language that this runs in, counts from 0. 0, 1, 2, 3. And then in addition to all of that, there's a timestamp and a date, which will tell you exactly when the recording was started. This also means that the recordings go into alphabetical order according to the order that they were created in. Now, this means that this script takes care of a lot of data processing for us. This is not always the case. If we are managing files that we have collected, we don't always have the luxury of a script automatically naming and arranging our files for us. So, on that note,
we'll talk about data management. And this is especially helpful for, say, elicitation sessions, maybe you're recording stories, any type of data really, or any phonetics experiment that you might be recording that doesn't have this particular software. Okay, so we'll talk about data handling and processing. Próxima. Okay. So it's really important to manage your data, and if you've ever recorded something and then years later gone back and tried to figure out what you were doing and when and with who and with what equipment and you can't remember, then you know very well what I'm talking about. And if you don't, then I don't wish you ever have to live through that. We should all be able to avoid it. A primeira regra é nunca apagar nada. Nunca apagar nenhum arquivo que você grava. Mesmo aqueles que... Vocês viram, a gente estava gravando e às vezes não saía bem, né? A gravação. Mas talvez dá para salvar aquele arquivo de alguma maneira, né? É bom saber. E, por exemplo, não sei quem que foi, mas repetiu... Foi Davidson, né? Que repetiu a mesma palavra, tipo... 3 vezes, não sei, talvez o falante fica chateado no final e pronuncia de uma maneira diferente, né? Então, é bom saber essas coisas de quantas vezes a gente gravou. Então, nunca apagar nada e sempre fazer cópias. Sempre fazer cópias, né? Eu já ouvi falar de um linguista que trabalhava na Amazônia e tinha todos os dados gravados num HD. Aí o HD caiu no rio, aí sumiram todos os dados, né? É horrível, você imagina fazer trabalho de campo durante 1 mês, 2 meses, aí voltando... Não, eu ia chorar muito também. Nossa, e não é só chorar, senão ter que explicar para a instituição que deu o financiamento que você gastou dinheiro e não voltou com nenhum dado. Então, na aldeia, normalmente a gente faz... tem os dados no computador, aí faz uma cópia num HD e outra cópia em outro HD. E, se eu for entrar num barco, eu não vou colocar o computador e os 2 HD na mesma mochila, né? Vai separando. Aí, se cair uma mochila, ainda tem um HD separado para salvar os dados. Mas, realmente, é um problema na Amazônia. Tem que pensar nessas coisas. Outra coisa é umidade. Às vezes, o computador, as máquinas, os HD, se eles ficam fora durante um tempo na aldeia, talvez eles vão pegar muita água ou muita poeira e vai estragar com o tempo. Então, também é bom dividir as coisas. Então, eu acho que o mínimo seria 3 cópias. 3 cópias já você tem... você pode dormir à noite, né? Sabendo que, pelo menos, se alguma onça comer um HD, você tem ainda mais 2. Ok. Outra coisa é que, por exemplo, às vezes a gente faz uma gravação e o som fica muito baixo, digamos, o volume fica muito baixo. Aí a gente quer aumentar o volume, aumentar a intensidade, a amplitude da gravação, mas qualquer modificação, transformação que você fizer aos dados primários, você não faz no arquivo original. Primeiro, você faz uma cópia e guarda a cópia original. Aí, pode fazer alguma transformação, digamos, cortar uma parte da gravação para isolar uma palavra, uma pronúncia de uma palavra, ou amplificar a amplitude, né? Esse tipo de coisa sempre faz e vai renomeando a cópia para saber. Normalmente eu faço nome do arquivo _amp, que quer dizer amplificado. Isso é também para filtro. Por exemplo, a gente estava falando, olhando para os dados de fluxo de ar, vocês viram que o 0 não aparece no valor 0 real, né? Então, uma alteração que é importante de fazer com dados de fluxos de ar é recalibrar os dados para eles tiverem um 0 real, né? Para isso, a gente precisa da gravação 0 e precisa... you need to subtract the 0 recording values from the real recording values. Então, isso é uma transformação matemática. Aí, você guarda a cópia original e tem outra cópia com a transformação filtrada. Tá, próxima. E os metadados. Isso é importante para qualquer projeto, né? Então, a gente tem uma planilha e, na planilha, entra muita informação. Na verdade, pode ter ainda mais campos do que participante, local, data e assunto. E nós incluímos também tipo de atividade que foi gravada. Por exemplo, se for um experimento fonético, se for licitação, se for entrevista, se for um texto, uma narrativa, qualquer coisa. Então, entra tudo isso. Também colocamos eu estava falando, eu acho que ontem, o modelo do microfone, o modelo da gravadora, não só o modelo, mas também a gravadora específica, né? Eu tenho, por exemplo, 3 Zoom H4 Pro, mas cada um tem um nome diferente, né? Aí, se quebrar a gente consegue saber qual que não está funcionando bem. Aí, tendo o nome, digamos, da gravadora, aí a gente sabe qual que é. Qual gravadora que a gente usou para alguma gravação que saiu mal. Então, próxima. Ok. Para cada arquivo que a gente cria, a gente coloca muita informação para, no futuro, e o futuro pode ser a mesma noite ou o dia seguinte, não é muito para frente, não. Pode ser no mesmo dia, você fizer muitas gravações, aí você olha os dados e, às vezes, pode ficar muito confuso. Então, ao renombrar os arquivos, eu coloco muita informação. Então, aqui tem o template que nós usamos para o projeto Panará, que inclui muita informação. Então, aqui no início tem um código, o ISO code. Não é realmente o ISO code, é um código de três letras, mas o ISO code para a língua Panará usa um nome para a comunidade que eles não gostam. Então, a gente troca, mas pode usar o ISO code. Aqui a data. E a data aparece no formato ano, mês, dia. Assim, no computador sai cronologicamente. Se você for colocar mês ou dia antes, aí vai aparecer talvez todos os dados de janeiro de qualquer ano que seja, né? Então, não aparece todos os dados de um ano só, de uma ida para campo só. Aí, depois, o nome do falante. Aí, o nome do pesquisador, que aqui foi o SUNY. Aí, o nome aqui, o título, digamos, do arquivo. Aqui é a história pré-piquim, tipar, crema, mampenho. O que é pré-piquim? Um ser mitológico. Um ser mitológico que comeu os panará e depois morreu. Aí, isso aqui também é importante. Aqui tem o canal 1 e o microfone, que foi audiotécnica. Esse microfone aqui é um shotgun microphone que a gente usa. No segundo canal, tem o Shure Beta 54, que é aquele microfone de cabeça hypercardioid que a gente estava falando ontem. Então, sempre que a gente grava, temos um shotgun mic e um headset mic. E aí vamos usando o som do canal que tiver melhor áudio. E aí a extensão, né? Porque a gente poderia ter também, por exemplo, um text grid com o mesmo nome. Então, tudo isso seria útil, né? Aqui tem o nome da narrativa. Where did we put? It doesn't say narrative. Mm-hmm. Mm-hmm. Mm-hmm.
Unless it's an English thing,
Mm-hmm.
but then that's the title of the file.
Mm-hmm.
That will then link to all files that have the same
Yeah.
title linked to a recording event, and then that recording event has metadata about it.
Uhum. Então, isso, vocês não precisam entender exatamente a organização dos nossos dados, mas vocês têm que ter um sistema de organização para os seus, e vocês têm que entender e conseguir usar sempre, sem falta, tá?
E documentar o sistema.
E se vocês foram arquivar os dados, incluir a estrutura dos metadados na coleção, na coleção, né? Junto com os outros arquivos. Algumas perguntas sobre isso? Faz sentido? Certo. Então, fazemos um intervalo. São agora 4:06, voltamos às 4:30.
Test, test, test. Test, test. We may try to start again. Test, test. Okay. Okay. So, hello everyone. Let's start again. All freshly caffeinated. All right. Don't worry. All right, let's go. Oh yeah, Sunny's not here. Okay. So I should just say next slide to someone else. Próximo. Obrigado. Okay. So I want to talk about if one doesn't happen to be able to borrow one of these pieces of equipment, the faculty at Brasilia should have 2 of these. If you're unable to borrow one of these, you only need a little bit of data anyway, there are other ways to get this kind of data, even if it's not exactly the same thing that you're measuring. But if we think about what nasal airflow data is providing us with, we can search for suitable substitutes. It's giving us a continuous measure, we would call it, of nasalization. Instead of just nasal or not nasal, it gives us everything in between. It tells us how nasal something is, how much nasality there is. And in that sense, the advantages that nasal airflow data offers us can also be offered by something called nasalence. Sometimes you'll see this called nasometry as well. We'll use the term nasalence. It's much more common in the speech sciences. So one microphone acoustic measures that are only taken with one microphone are, as we mentioned early on, not great for measuring nasality in sounds that are continuants. Sounds like vowels, semivowels, things where there's not a simultaneous constriction going on. If we're talking about consonants, as we've already discussed with a few people, it's often quite easy to go from a single acoustic signal and to figure out some things about the nasality, provided that you measure the right things. But often you can see them on the spectrogram, or the waveform, or both. But if we don't know if that will work, and we need some kind of nice measure that gives us continuous values instead, well, we might need to do something different. So nasalence it is. Nasalence is also an acoustic method most of the time, almost all of the time. It's just that there's a crucial difference. It uses 2 microphones. We do not use the entire acoustic signal from the microphones. Rather, we just look at how intense the signal is from both of the microphones. We just look at how loud the signal is in both cases. This works on a pretty simple principle. If you think about it, if we were to put a microphone inside of someone's nose or something like that, just directly inside, and somebody produced a bunch of oral vowels, completely non-nasal, with the velum completely shut. That's actually unusual for vowel production, by the way. It's rather unusual for the velum to be really, really closed for vowel production. It's normally open the tiniest of bits, and for nasalized vowels, a lot more. But which is why we need an oral baseline, because sometimes oral is slightly nasal, actually, in the measurement that we're taking. Exactly. Thank you, Myriam. But sometimes, at any rate, I'll just do this for good measure. Completely oral vowel. If we think about that, and we have a microphone inside of the nose, how loud do we think the signal from the microphone would be? Probably not very loud. Because the nose is physically closed off from the rest of the vocal tract, the sound isn't going to come out of the nose. And so that should also work if we put a very directional microphone right in front of the nose. We should expect that there is sound sort of radiating out of the nose, just like there's some sound radiating out of the mouth. And we should expect, if we can get just the sound that's radiating from the nose and we can see how loud it is, actually that should be able to tell us a lot. Likewise, we might want to simultaneously see how loud the noise coming out of the mouth is at the same time. So this is why we use 2 microphones. But if you were hard-pressed in theory, you could use 1. Actually, we'll be able to demonstrate a little bit later today showing you with just 1. Now, at any rate, nasalence methods are pretty cool in general. They've been practiced for a very long time, as we're going to talk about for a little bit today. They've actually been around for more than 50 years at this point. And many among you will be familiar with the earbuds method, which was very, very well received here. A couple of Amazonicas ago? 2017, I think it must have been presented in, but yeah. But at any rate, that was very well received, and it has been used by Amazonianists in many, a few cases now already. But there's some minor problems with this. It's not actually totally known yet, up until recently, whether it is a reliable method to use for measuring nasality. And there's some reasons for this that we'll get into in a second. The good news is, and I'll ruin the ending for everyone, but the good news here is that yes, it is more or less reliable if you follow a few simple rules. So you can definitely still do this if you want. So the earbuds method, in other words, is just another kind of acoustic nasalence. It also means that you can do this without using earbuds. If you're so inclined, you could use 2 microphones. So in general, this is the method that you need 2 microphones for, and optionally some other stuff. Próximo, por favor. So classic nasalence will look something like this. We don't need to play the video to get an idea of what's going on here, but on the left, we have sort of the gold standard of nasalence devices, the K-Pentax nasometer, which has been around in more or less its current form for a few decades. The problem is that it costs more than $10,000. It's very expensive. It is also very precisely calibrated. So you can use this and you have some confidence in what it's telling you. There's never going to be problems with the equipment. The amount of nasality that it's telling you exists in the signal is going to be a known fact, essentially. There's no potential problems with calibration or anything like that. However, instead of paying $10,000, many people have decided to make less expensive versions of the nasometer. If you look carefully, this was, I think the university that this was at was in Pernambuco. I can't remember, but Alves Torvela was working on Aikana, the language. That's an Aikana speaker, pictured in the slide there. And if you look carefully at what's going on here, we can see some labels 1, 2, and 3. Label number 1 is the nasal microphone, which is above our mysterious object. Label number 2 is the oral microphone. Label number 3 is the mysterious object. I'm pretty sure that the mysterious object is just a sheet of acrylic plastic, but it could just as well be like a clipboard or something. What would a clipboard be in Portuguese? Good. Because this would work very well if you removed like the metal part. It's like exactly the material that you'd need and the size that you'd need, and you could probably get it for very cheap.
You need to be able to cut out something.
And you do have to cut out a chunk for the upper jaw to fit into. But other than that, I mean, you can just pay somebody who has a saw to do that. You know. Yeah. It's a lot less expensive than $10,000. But at any rate, however you'd say a clipboard, the thing that you clip papers onto and you can write on, one of those minus the clip is probably very good for this sort of thing. But at any rate, you need a rigid plate that extends for some distance away from the nose and the mouth, and which can be pressed against the upper jaw, not uncomfortably, to separate the oral and the nasal signals when you're recording with 2 simple microphones. As we'll revisit later, these are literally just headset microphones, I think, that are on the right. They're just taped to the board. Próximo. You don't have to. Stop. I don't know why that played. You have to stop the video. Go back. Oh, it did. Never mind. It did stop. Okay. So there's the fancy, expensive kind of nasalence, and then as I'm putting it here, there's the tape it to a clipboard nasalence. I figure that this is more likely to be accessible here, since if it costs $10,000 in the United States, it probably costs 3 times as much here. But I don't know for sure. I've never tried to import a nasometer. Nasalence data, however you decide to collect it, you need to use 2 identical microphones. It's good to use the ones that you have, but they do need to be the same. They need to be the same type of microphone. They need to be the same exact microphone. Name, model, manufacturer, everything should be the same. You also want to mark them for the channel that they're recording, because you always, in theory, should be using the same microphone or earbud, as we'll talk about later, for the same cavity. You should have one marked for the nose, one for the mouth. Ideally, you will use a very directional microphone. Something like a hypercardioid microphone, which we mentioned, rejects almost all of the sound except for what it's pointing at. There are some problems with this, of course. It turns out that hypercardioid lavalier microphones, which would be ideal for this, these are the ones that normally clip onto a collar, but which you could just as easily tape to a rigid object or even tape to the speaker's face if you lacked a rigid object. They're expensive, relatively speaking. However, they're much less expensive than a $10,000 nasometer, so this might be more easily within reach for people than that. There's a series of hypercardioid microphones shown here. They're like black on a black background, so they don't actually show up very well here. But you can see that several of these are in fact labeled hyper or supercardioid. Right. And I've also included a headset microphone. These are not all going to be lavalier microphones. You can make like Alves Dolveira and just tape some headset microphones to a clipboard, which is also fine, because headset microphones are usually highly directional. And that is what we need out of a setup like this. Próximo. I'll add, we mentioned some brands on that slide, but the specific brand isn't important so much as the characteristics of the microphone, which we went over the terminology yesterday. You will now know the terminology to look for if you choose to buy something in this area. Right? We want directional or cardioid or hypercardioid. And it just needs to be lightweight, and it could be attached up here. It needs to be just like a little tiny microphone on a wire, essentially, optionally with a headset attached. I do need to make a practical point here, which is probably not going to be lost on people, but the cheapest microphone is the one that you already have. So if you happen to have 2 identical microphones of some kind, and maybe they don't completely suit the specs that I have just given, and you need a little bit of data on some language. It's not going to be the foundation of your entire master's thesis or paper or term paper or whatever it is that you're trying to do, but you just need a little bit of data. Well, you could probably just use 2 of something which you've already got, and you'll be fine. If you're not using a highly directional mic, you'll probably want to use a baffle. A baffle is the term that we'll use for the plate that blocks the microphone signals from influencing each other. So you will have to cut a baffle if you use, you'll definitely have to use one if you're using omnidirectional microphones. And you can get omnidirectional lapel microphones that are relatively inexpensive. So I don't know how well precisely. Oh, shoot.
Are you okay?
Uh-oh. Oh, no. Oh. I think more water is lost than anything else. Okay. You all right? Oh, darn. That will be interesting going out. Okay. Oh, wow. Did that like...
Oh my God.
It broke. So all of it's on the floor. Oh, that's bad. I don't think I've ever seen that before. That's bad luck. Okay. Well, we can continue. Okay. There was a water cooler incident. Anyway, something that's very similar to the microphone that Alberto Vera seems to be mentioning here, using here, is one that I've personally used in the field, the Shure WH20. If you were to buy 2 of those, it would cost something like $120 US, which is, again, not incredibly cheap, but it's much less expensive than other things that you could be buying. And you know what? Again, if you've got something like these sitting around, you may in fact just be able to use 2 of those if they're obviously the same microphone. Thought?
I added a new slide.
Oh.
Você pode sair da apresentação? I added another slide on how to improve the method.
Ooh, not here, but...
I can proceed. Some materials that one can use to improve it.
Okay. Sure.
So the material that you could use for this, like Matt was saying, could be all kinds of things, and he gave a lot of examples of it, but I've been doing a little bit of research on the kind of material that would be easy to cut and the right thickness, and also some material that you can glue on either side of it, possibly for sound absorption to reduce the contamination of one signal by the other. So any kind of fabric that you glue on both sides, or even like a cork sheet, which is very sound absorbing.
Yeah, that could work. That could work. I don't know how well cardboard would work, but that if you're really improvising, I suppose that you could use that in place of nothing. But it strikes me that cardboard would not last very long in an Amazonian village.
It's not cardboard, it's an MDF board.
Oh, it says cardboard.
Oh, yeah.
So anyway, okay, próximo. Oh, próximo. Okay. So one version of acoustic nasalence that some of you will have seen or heard of before is this earbuds method. To my considerable interest, it seems that actually Stewart and Kohlberger might not have been the very first people to suggest this. I seem to remember, well, I put it in the header here. So Audibert and Amelot also mentioned this in some way. It doesn't seem clear to me that they implemented it. But at any rate, the paper that you'll see this talked about the most in is Stewart and Kohlberger 2017. This is an open access paper in LDC, so if you're curious to read about it, you should be able to get it very easily. These figures are actually, I think, only half from that paper. The other one is from Breuil and Stewart, which is behind the little Zoom window, so I don't know the year. But it is also up there in the slides. At any rate, this is an example from, I want to say, Quechua here on the right. The important thing to notice is that we have 2 signals. We have the nasal signal in red and the oral signal in blue. Again, this is, so okay, they have arranged it in physical space. Nose is on top of mouth, right. And what we should notice from this is that, for example, if we look at this first syllable here, this kui, guinea pig in this case, we see basically no nasal activity. One of the signals is coming from the nostrils, the exit to the nose, and then the other one is coming from a microphone put near the mouth. So in a syllable like kui, which is completely oral, of course, we get a strong oral signal, which is pretty loud, but not anything really from the nasal signal. In the next word, we see more of a mixed signal. There's this kami. In this case, the E is nasalized from the M in Quechua, apparently. And so we see this rather strong signal beginning about halfway through the ah in kami that is begun, that gets picked up by the nasal microphone. And it continues on through most of the rest of that word. And so on. We get nasal signals where we expect the velum to be open and it's pretty much shut. It's quiet whenever the velum should be closed. So actually, it seems pretty reliable from this figure. Próximo. Generally, what people do with these signals then, and this is true beyond the earbuds method as well, but I'm demonstrating it with earbud data here, is to normalize the channel intensity, basically to just perform a calculation that accounts for differences in how loud a channel might be in general. This would adjust for things like how far the microphone was from the nose or the mouth. How responsive the microphone is, things like that. So you would essentially be normalizing this in some way. I'm actually not quite sure how they do. It's some kind of ratio measure. But what they then do is they take the ratio, and this part is the part I'm sure of, the ratio of nasal intensity to, I want to say in this case, they're doing oral intensity. You'll also see people do proportion of nasal to nasal plus oral, so like the amount of the total signal which is coming from the nose. Either one of those could work for various calculation purposes. So if you do nasal divided by oral, as in this case, you'll get a number that's either negative or, well, wait, either above or below 1 in this case. I'm not sure if the line there is for 1, but it probably is. And so we can roughly take that to indicate when the green signal is above the thin green line, we can take that to indicate that there's more nasality than orality. And when it's below the line, the signal is more oral than it is nasal, right? When it's above, it's more nasal than oral. So these are two Brazilian Portuguese words. I do not know what tapitão means, but that first one is tapitão. The next one is inflação, and I figure that's inflation, but we can see that actually the in inflação is not very strongly nasalized. It's like it's maybe a little weak in its nasality, but the at the end of both of the words here is rather strongly nasalized. It goes above the line that we can think of as the cutoff for nasality. I don't know why the entire rest of this plot exists. For what it's worth, the visuals that come with the earbuds method are often very confusing. I don't know why there are multiple waveforms on top of each other, twice in this case. The green line would be enough, technically. You were about to say something.
It might just be that. So one of the things that we can see is that there's signal on both sides, right? Like there's sound for, like with the nasal airflow, when there was no airflow, we were seeing no signal. But here what we're seeing is that there's signal on both sides all of the time. And so it's very sensitive to microphone placement. It's very sensitive to any amount of sound that passes from one microphone to the other. And so, I mean, it is interesting that there's actually quite a bit of nasal airflow, but it might just be that there was also a lot of oral airflow during the E. And so it might be, you know, one of the ways in which this method is a little bit less precise. It may be that it wasn't that nasal, but it could also be that maybe there was just more airflow coming out of the mouth here that's kind of obfuscating the pattern.
And to continue, I should add, technically not airflow. So this is just the sound being received by the microphones. So it isn't an airflow signal. We can think of it as tracking an airflow signal pretty closely. Point being, when we take a ratio measure like this provides us with the measure that we call nasalence. Nasalence is just some kind of numerical score that tells us how nasal something is. There's several different ways to calculate it, but they all sort of point at the same thing. The higher the number, the more nasal it is, generally. And this sort of thing is very generally used to gauge nasality based on acoustic signals, because acoustic signals are easy, right? Sometimes a clever trick is to bandpass filter the signals, like you might just get information on the low frequency response from each of the microphones or something like that. But at any rate, various subfields do this. Various researchers have done this for a really long time. It's a popular method, especially with clinical subfields. Prossimo. Now, there are some advantages to just using earbuds like they suggest, right? They're very robust, you could say, robust to the demands of fieldwork scenarios. They work well in fieldwork scenarios because they're inexpensive, they're easily replaced, they're very, very light. You probably are already carrying some anyway, though whether you want to put them on someone else's face is another question, if they've been in your ears. Whole other question. But you probably already have one if you need to improvise. And in a few cases, you can even purchase them locally, or closer to locally. They're also rather similar in setup in the way that we're told to set them up to the more complex nasometers. One thing that we're going to come back to is that they lack the baffle plate. Nasometers always have that plate. And the earbuds method paper actually explicitly says that you do not need to use the baffle plate. We'll return to that point. There's also a very easy learning curve. In theory, you just hold an earbud up to somebody's nose. We'll demonstrate this a little bit later. It really is that fast. Like you just get a signal from it, and it works surprisingly well. Participants are also generally familiar with earbuds already. The only strange part of it for them is that they're putting them on their face instead of in their ears, right? But once you explain what they're doing, it's presumably not very intimidating. Prossimo. So the problems, and there are several, but we'll spend a few slides addressing these afterwards and finding some workable solutions, is that earbuds are not assessed for fit with what we would call ground truth measures, measures that we know reflect the actual amount of nasality. So for better or for worse, the highly calibrated, precisely manufactured nasometers are really the best ground truth that we have. There's hundreds and hundreds of studies that have been done with the K-Pentax nasometer, TM. Even though it's very expensive, there's a reason everyone uses it, which is that it makes your data instantly comparable with everyone else's who's ever used it. Different nasometer setups, there's more than one nasometer that's manufactured. Of course, these are also subject to some similar issues. So there have been entire papers written about how different nasometers will give you slightly different measurements for very similar phenomenon, right? But these consistency issues are relatively small. Earbuds could introduce much larger consistency issues because earbuds are not manufactured to the same standard as something like the K-Pentax nasometer. They're made very cheaply. Some of them might not actually respond very well as microphones. We had a fun experiment using the earbuds that you get on airlines because everybody just gets a couple pairs of those at some point. And we found that they really couldn't record any signal at all. When they are used as microphones, they're incredibly insensitive. You have to kind of go to get them to produce any sound. And talking at them produces basically no signal. So you have to be careful about how cheap the earbuds are, essentially. So this could become a very popular fieldwork method, and it is already sort of becoming popular among Amazonianists. You can see that there's at least these 3 papers that I'm citing here which have used earbuds. And some biases that might emerge over time in the sets of collected data, they could eventually become an issue. For the fact of the matter is, as of now in these slides, we don't actually know whether there will be an issue. Prossimo. There's an entire paper. It's worth reading, even if it is highly technical. I've told people that phoneticians are very interested in developments in field data collection because we just like data generally, and we want new and interesting data, among many other things. At any rate, Carignan, 2024, seeing that the earbuds method was developing, decided to say, I have a nasometer, and I kind of like fun data collection questions. So I'm going to actually be the one to check how precisely the earbud method works. So basically a lot of the issues I mentioned here are also raised in this paper. There's a good summary in the introduction. And he clarifies that he's going to check these against a ground truth, which is nasometry. So he happens to have a nasometer because he studies nasality. He's in a lab. He has a Glottal Enterprises NAS1 SEP handheld nasometer. The SEP refers to the acoustic baffle plate that goes between the two microphones. He sets this to record at the same time as 2 different pairs of earbuds because he noticed that not only are the specific recommendations that they make to use various specific things here, but they specifically mention that you should use silicone-tipped earbuds with the little soft silicone tips that are rounded at the tip, specifically so that you can avoid picking up too much signal from the other microphone. The justification is that you must use the silicone earbuds so that you get a very directional response when you use them as a microphone. If we remember how shotgun mics work, there's a what we call an interference tube inside of shotgun microphones. The silicone tip is supposed to be sort of like the interference tube in this case. But of course, no one has really done detailed studies on the response patterns of earbuds when they're used as microphones. So whether that has the desired effect, it's not really clear at this point. But there are 2 types of earbuds tested at any rate, because Stewart and Kohlberger are really clear about what you should and should not use. And there's even a big figure in the paper that has the silicone earbuds with a big green check mark, yes. And then the flat earbuds, the ones that look like little tiny speakers with like a wire mesh covering. It's kind of a circle shape. And they have those with a big X next to them. Don't use these. So because this is an unexamined assumption, Carignan decided to test both kinds of earbuds. As we'll see, it's a good thing he did. Prossimo. So this is what the actual study looked like in his case. So there's one minor problem which led to this slightly weird setup, which is that, and that is the author, by the way. The author was his own subject in this case, in the study. It's a one-person study, but he generated a very large amount of material. So there's lots and lots and lots of words that this is being tested on. So he has 2 nasal earbuds positioned on either side, 2 of them here, 2 of them here. And they're taped below rather than placed inside the nostril. Apparently he talked with Stewart and Kohlberger and they said, well, we don't put it inside of the nose anymore, we just put it near the nose. So that's the latest recommendation, so that's what he did. There are 2 types of earbuds. Notice that the flat ones are on the right in this picture. The silicone ones are on the left in this picture. To be thorough, this is the picture of the actual setup that he recorded these in. There's a second picture in the paper because he switched the sides of the earbuds and then recorded everything a second time. So as to be thorough about, I don't know, perhaps one of his nostrils is differently shaped than the other one, or some of his sinuses are different internally. So what he did is he balanced his data, right, effectively. He had 2 conditions and he balanced for them. At any rate, prossimo. Now, this is what it looks like with the nasometer setup. The nasometer's microphones are attached to a little box that you can see on either side of the baffle plate. And in theory, the main reason he taped the the earbuds to his face is that he was holding the nasometer. It has a handle. So he couldn't hold all 4 earbuds up at the same time. But he later goes on to recommend that people could actually just generally use medical tape or blister prevention tape, I think is what he used. The kind that you put on your foot if you have new shoes. You could generally use that, probably, and it would be a lot easier than having your speaker hold them up to their face. It would also prevent speaker fatigue, I would say. They would get less tired. But that's what the setup looks like. All the microphones are kind of pointing in the same location. Prossimo. And these are his results. Basically, what we're looking for is a correlation between the level of sound, right? Actually, the nasalence, the calculated nasalence, from each set of earbuds and the nasometer. And on this side, we have the flat earbuds. This is the nasalence that the flat earbuds measured, and this is the nasalence that the nasometer measured. Now, if these always produced exactly the same measurement, all of the points would be along this dotted line. That's what we call the identity line. In this case, it's a slope. It's basically an equation of x equals y, if anybody remembers their algebra, right? Where the two values are always equal. In this case, it would be earbuds equals nasometer at every single point. Likewise, on the other side, the other figure is for the silicone earbuds. And again, the closer it is to the dotted line, the better. Because the closer it is to the dotted line, the better the correlation is. The better the earbud measurements resemble the nasometer measurements. So it turns out that in various ways, the flat earbuds actually do a little bit better than the silicone earbuds. And it's not just the distance from the line that we're looking at so much as the shape of the lines that you can draw over this data. He drew some estimated functions over them. And what we can see is that all of these functions broadly show an increasing pattern. They broadly point up this way, all of them. So generally, when the nasal signal gets higher in one of them, it gets higher in the other one. How much? Not precisely the correct amount, but very close to the correct amount. Here, it's much more mixed, it turns out. There's a lot going on. It's very strange. And in particular, there's this huge over-response here. The earbud nasalence is actually way too low in this area, excuse me. And so all of these points have a nasalence of about 50, but they have anywhere up to like 80 on the nasometer. And then there's a huge under-response down here. So the opposite problem happens. It is not at all clear, even after he wrote this paper, why the response pattern looks like that. There's actually bigger problems, though. Prossimo, which is that actually the silicone earbuds turn out to be very bad at estimating nasality over time. So he took all of the, I think, vowel and then nasal coda sequences in the entire data set, and he just shows us the estimated nasalence over time. At the left edge of each plot is basically the start of the vowel. And then at the right edge of each of the plots is the end of the nasal in the vowel nasal sequence, VN, right? And the dotted line in the middle is more or less where the boundary between the vowel and the nasal is. So we should expect to see the airflow kind of going up somewhere to the right. Excuse me, I did it too. Not airflow, nasalence. We should expect to see the nasalence going up after the dotted line at least, and probably a bit beforehand too, because we know that nasal codas nasalize the vowels that come before them very commonly. What we get instead is a little discouraging. So the silicone earbuds are in blue, and look at their response. It's like flat. It doesn't respond much at all for some reason. If we look at the green and red lines, green is the nasometer. That's like the best quality measurement that we have. The red line from the flat earbuds actually does a pretty good job of tracking it, considering that it's just a pair of earbuds. And then we look at the scaled nasalence. So this kind of takes all the lines and makes them similarly on similar scales to one another to compensate for the fact that this is basically flat. When we blow these up to the same scale, the type of problem becomes really apparent. For some reason, the nasalence is coming too early or at the wrong time when we're using the silicone earbuds. So it's not clear at all why that is happening, but it's not great. And this is a fairly large data set, so the fact that it's happening across that big data set is not great. Prossimo? And a very small error bar, yes. So these are not error bars that are big. These are rather certain measurements because of how tight the error bars are. So there are many factors that can make the earbud signal not too reliable, it turns out. But it heavily depends on the type of earbud that you use, as it turns out, and certain other details of the setup. So it seems that even silicone earbuds do give us a decent signal, but it's not as great as we might like. So for improvement purposes, we might want to use flat earbuds. Now this is a bit strange because this is the opposite of what Stewart and Kohlberger suggested. But I just want to make it clear to everyone. So far as we know, the more accurate earbuds are actually the opposite ones of what they originally suggested. Why might that be? I am full of questions here too, but I speculate that it might have something to do with the fact that his recordings were made with a baffle plate, which was provided by the nasometer in this case. So it seems like maybe silicone was better without the baffle plate, but with the baffle plate, flat might be better. That's my wild guess. And if you're going to use a baffle plate, just get flat earbuds in that case. They'll probably work fine.
The silicone ones are also more sensitive to directionality, I
Yes.
assume, because it's kind of like a mini tube, right?
Yes.
And the silicone is a little sound absorbing.
Yes. All of those things. The silicone earbuds are much more directional, probably, than the flat earbuds. So it could be that like the very precise direction that they are pointed in the Carrington paper might have mattered. But even if that was the case, and I'm sure someone could argue, oh, he should have pointed them better, and then it would have worked better. We really don't want a method that breaks so easily, like to be in use. So we would rather use the ones that it's easier to set up. Like we've said before, make sure you're marking a specific microphone/earbud to use with a specific cavity. You want one to always be pointing at the nose, one to always be pointing at the mouth, because manufacturing consistency is sort of a problem with inexpensive earbuds. They might have very different response levels across different pairs of earbuds, even across the two earbuds in a pair of earbuds. They might be different. I will also recommend, I don't think Carrington calls for this, but I will say just tape them to people's faces. They shouldn't have to hold them up the whole time that they're recording, and it keeps them pointed in the same direction the whole time, which is better for consistency. Ideally, if you've got a baffle, once you've taped the earbuds in place, you could even tape them to the participant's face and then put the baffle on. That would also work equally well. And they wouldn't have to hold it up the whole time, just when they're recording. Ideally, you might also, again, counter to the original advice, you might not want to buy the cheapest earbuds available. You might want to go up a step or two in cost. Buy the $30 earbuds instead of the $10 earbuds, or something like that. One last point, though. Earbuds, for the most part, are omnidirectional when you use them as microphones. It should be pointed out. The silicone tips control the directionality a bit, but when you use them as microphones, they pick up sound from everywhere. So this means that when you're doing the earbuds method, unlike if you're using a fancier microphone, you have to very strictly control the background noise because everything will get picked up. And that could be another confound in making various measurements. Próximo. Now, we can do a little tiny demo. I think that próximo. Oh, yeah. So I'll briefly mention this. People, if they have a computer, are free to try to follow along. I don't know if we think we have the time for everyone to try this, but this could be like, yeah, this was like a homework thing, right? Yeah. So basically, we're not going to try it here in groups, but you can try following along with this at home. Do they have the slides available somehow? We'd want to share these like steps at least. But oh, that's great. Yeah. So screenshots of the slides will make it into the group chat. Okay. Now, at any rate, Stewart and Kohlberger say that to do the earbuds method, you should use a digital recorder. You just plug your headphones into your digital recorder, and it treats them as a microphone, and you're good to go. We've actually had some trouble doing this, so we reached out to the authors to ask them for some technical details. We haven't heard back from them yet because, in fairness, we emailed them yesterday. But we're hoping that we hear from them before Friday. If we hear from them later, we'll also let people know. Instead, we can follow along with the process by using any laptop computer, though I have had better luck with my PC than with a Mac. I think the Mac headphone jack will not function as a microphone input, whereas the one on most PCs seems to function as a microphone input. So if you have a regular old PC, this should work. Oh, that's true. Yeah, the EGG is only compatible with PCs. We never mentioned that. The airflow setup that we were using. There's a reason that we use Macs personally, but we have PCs for data collection. Right. Anyway, but that's usually not an issue for people. People, I don't think, use Macs too frequently here. Anyway. But we want to use, if we're recording directly onto a laptop, which we might be able to do, I prefer using Audacity for this over Prot, which we'll talk about more soon. Audacity lets you very precisely control your audio inputs and outputs. So you can pick precisely that you would like to record with your headphones. The official download for Audacity is here. Notice that there's this weird link at the top that they're trying to get you to use. You don't need to use it. It makes you download this weird like download hub software that you don't need. You can just download the installer for Audacity and it'll let you install it. So use the second link. You don't need to use the first one. Próximo. Once you have it configured, you plug your earbuds into your headphone jack. And you select them. If your operating system asks you at that point what you've just plugged in, you lie a little bit. You lie and you tell it that it was a microphone. Surprisingly, this is enough, it turns out, for them to be treated as a microphone. I would have never suspected that, but it really is that simple. Then you open Audacity, which should be somewhere on your computer. You select your headphones as the audio input. Sometimes, because they're not what your computer thinks they are, you need to try a few things and make a few test recordings before you figure out which one is your earbuds. The easiest way to test whether you've got your earbuds, of course, is to make a little recording. And at the beginning of the recording, you just go like this on the earbuds. Gently. And if the tapping produces a little audio signal in the recording, you'll know that you have the correct setup. And then at that point, you press record, red circle, press stop. When you're done, black square. At least on my computer, this doesn't give me two separate channels. Rather, what it gives me, próximo. Rather, what it gives me is a single channel that's duplicated to two channels of a stereo file. But if you really want to see what the oral versus the nasal signal looks like, you can just move the earbud between the two locations. You can figure out which one of the two earbuds is recording. It was the left one, usually for me. And then you can just say the thing once, point it at your nose, and then point it at your mouth, and say the same thing again. So the first token of this sentence was recorded with the mic near the nose. The second one was recorded near the mouth. They're not as different as one might like, but they're visually different. You can tell that they're different waveforms. And you can even see that the nasal signal diminishes quite a lot towards the end of this sentence where there are fewer nasals. This sentence was, Mariana made the marmalade. So there's a lot of at the beginning, and we have a pretty strong nasal signal. And then it tapers off towards the end, whereas the oral signal stays strong. So the oral signal, to be clear, is this one over here. It's both of these, but it's just the same twice. So this is the oral signal. This is the nasal signal. We see that the nasal signal goes and goes and goes, and then it kind of stops. And the allayed, basically, part of the sentence is what's happening there. But in the allayed part, the oral signal keeps going. So it's giving us some differences that look about right. So it really is that easy to get basic data like this, potentially. At any rate, we might note that these recordings look like the airflow data a little bit. If we were to open up, we'll eventually see this. If we open up our airflow recordings, which we took with these devices up here, we would look at them and we would see that actually they look strangely like waveforms. And this is especially odd because the acquisition utility filtered these for us, right? we saw these nice, big, kind of wavy airflow patterns, and not these things that look like they're just voicing waveforms. In reality, this is because you do need to filter the airflow data to get those signals. The airflow data actually sort of has voicing laid on top of it. For various reasons, you just filter it out. And so it's extremely easy. I think both Myriam and I have referred to nasalence data the wrong way, but it's also very easy to mix both up. They look really similar in their raw state. So you do need to know what you recorded, right? Crucially, however, we would never need to filter this. There's no reason to filter it because nasal airflow data has the addition of this low frequency signal. In addition to the little ups and downs from voicing, the signal also slightly goes kind of very slow ups and downs, which we see once we get the filtered figure, right? And there's nothing like that here. If you were to filter this in the same way, you would get nothing. Nothing would come out because you have removed all the info. But rather what we're looking at is actually the intensity in this case. We're just looking at how loud the signal is for nasalence, right? And in this case, I'm not measuring the intensity, but I am eyeballing the waveforms and seeing how loud or not loud the signal is. Okay, next slide, I think. So this would be, in fact, where'd it go? The earbuds thing. No, I mean, I think it said at some point, like, try an earbud thing at home. Oh, it's the next one. Okay. But at any rate, we do have... no, that's the readings. Well... oh. Well, okay, then why... Oh, yes. So wait, was that oh, okay. So we do want to do this today. I hope this gets screenshotted. Right. This is optional. Like, we want you to focus on the main questions of the course. But if you're really interested in trying this out yourself, you can try it out yourself. The instructions in the slides should work for most people. We can't guarantee what kind of a signal that you'll get, but you should get something. Maybe I'll hold off on demonstrating it right now, and we can do it like at the very beginning tomorrow, maybe?
I think we have time, because it's only 5:30, but also
yeah.
Rafaela just tried it at home.
Oh, yeah.
She has some stuff to say.
So maybe we should do both of those things. Maybe while Rafaela is going, I can set up, because it takes like 30 seconds. But anyway, we want people to try this if they can, right? If you've got a computer and you've got a pair of earbuds, you should be able to test it out. Just plug it in, download Audacity, like we said. Record the earbud signal. So far as we know, you can usually only get one earbud at a time, unfortunately, but you can switch between the nose and the mouth to see what the differences are. So we want to think about a few things critically. How is the structure of the data different from airflow data? I spoiled a little of that, forgetting that that was one of the questions. But also, what are the pros and cons, perhaps? Having directly experienced airflow, right? But also trying out the earbuds method. What are the pros and cons of both of these things? We want to think about that. There's actually a real discussion to be had about the nature of the trade-offs here. Question time, I guess.
Sim, então, Matt vai fazer uma demonstração agora com os dois, with the two lapel microphones, right?
One.
With one lapel microphone?
Well, actually, I can just use my earbuds.
Or your earbuds. I think we should do both.
It doesn't work.
Ah.
But Rafaela got it to work, so that's different.
Então, Rafaela, você pode explicar para nós como que foi a sua experiência tentando com os dois microfones lapel?
Oi, todo mundo te ouvir?
Sim, mas espera aí para todo mundo te ver.
Ok.
Pode sair da
Meu
apresentação?
Deus.
Agora sim.
Na verdade, eu tentei com esse aqui, que é um HoloLens. É um microfone, é um bom microfone de lapela, mas ele não funciona muito bem para o fluxo de ar nasal. Ele é dessa forma, são dois, e a vantagem dele é que ele prende com imã. Então, eu tentei prender aqui, um em cima, tentei prender embaixo também. E tentei com um menorzinho também, basicamente assim. Mas ele filtra o som do nariz. Ele filtra totalmente, mesmo na opção sem filtrar, a opção quando ele está azul, ele não filtra, em teoria, né? E quando ele está verde, ele filtra mais. Eu tentei também colocar dentro, assim, do nariz. Ele filtra todo o som do nariz. Eu acho que ele entende que o som, esse vento, né, é vento. Então, ele faz de tudo para pegar o som da boca. Aqui, e com esse aqui não funcionou. Infelizmente. Mas eu vou tentar com outros microfones na USP. Porque esse aqui ele só funciona para o sinal oral. Foi isso. Não deu certo.
Infelizmente, né? Mas é bom testar e já saber, né? Então,
Sim.
normalmente, digamos, para a maioria das pessoas, sobretudo para pessoas que não são fonetistas, que não são fonólogos, essa característica de filtração do som, né? Tipo, se você for gravar um podcast ou se você for apresentar qualquer coisa, né? Filtrar a voz para ela ficar mais não sei, melhor, para ficar melhor, né? Mas, enfim, o vento seria, na maioria dos casos, um barulho de fundo, né, que precisa filtrar, mas nesse caso é o sinal que a gente quer, então não ajuda muito, mas talvez por causa de que fosse um microfone de lapela, talvez com outro microfone pode servir com um microfone cardioide, talvez seria melhor, porque o microfone omnidirectional pega mais barulho de fundo, né? Então, se for um microfone que fosse mais direcional, talvez não tenha esse problema e não tenha função. Mas seria uma coisa bem importante de ver antes de comprar o microfone, né? Se você tiver mais sorte com outro modelo, fala para nós.
Eu vou testar com outros modelos no laboratório da USP, que tem outros microfones. E aí eu te escrevo se funcionou.
Certo, eu quero saber.
Okay, now it's on. So if people want, once again, they could come and get a look. This is going to be happening on this computer screen, not on the slides. But it's sort of surprisingly easy to get earbud-like acoustic data. I took the pair of earbuds that I normally use. These were not specially purchased. Plugged them into the computer, selected them as the microphone input. I've installed Audacity. I selected the correct input as the input. And I'll have to put the microphone down, but maybe it can stay on so it hears me a little or something. And I'll just record something very, very obviously that should work. I forget which earbud records, so I'm just going to hold them up. And I'll just record something entirely nasal and something entirely oral to start. And now I'll switch places. So what we can see pretty much, if we were to look at this right away, is that we get sound from both. It would be really nice to have a baffle plate to better separate the nose and the mouth here. But if I point the earbud at my nose and I hum, like in the first two, I get a very strong signal. If I point it at my mouth while humming, I don't get as strong of a signal. So if I was to take a ratio of those, oh, yeah, you could. So very strong nasal humming signal, right? And then if I hum again but point it at my mouth, it's less intense. So if I were to take the ratio of the intensity of this to the intensity of this, it would probably give me a number that indicates more nasality. This is a completely oral with the velum completely closed, and the opposite is true. I get less of a signal from the nose than I do from the mouth. So that would come out as probably more oral in that case. So it is actually quite effective. This is maybe not the most replicable or consistent setup that is possible, but once I had everything installed, I did just plug my headphones in and have it ready to go in about 30 seconds. So it's not difficult to set up at all. If people want to try it at home, you should try it at home. I think the hardest thing will be installing Audacity. I wonder what else we want to cover today?
I wonder if we could do a demo with the Lapierre mic and see if we have the same problem as Rafael.
Sure. Yeah, we could try that. What was the problem specifically?
It wasn't picking up anything from the nose because it was filtering it out as noise.
Oh, like it was getting nose airstream instead of sound. Oh, yeah. Yeah, if the headphones are applying some kind of filtration, like if they're fancy noise canceling earbuds or something, that can actually be a problem. This is one reason why cheap earbuds, the kind that still have wires, are actually good, because they probably won't have any fancy noise filtering. But this is, yeah, let's see if the microphone doesn't do anything similar.
While Matt is setting that up, actually the vast majority of time, a microphone with a cable is always better than a wireless microphone for any kind of phonetic analysis.
Very true.
Always better. So if you want to be doing phonetic, especially acoustic analysis, always get a wired microphone. And different types of wires and connectors also matter. XLR cables are better than auxiliary cables. That's the general rule of thumb, yeah.
So if you're doing the earbuds method, you're pretty much always going to be using something that has a headphone jack. And there's lots of microphones professional microphones that actually do come with a headphone jack. So it's fine, really, to have something that looks like this too. I think that when we have our full equipment and we are using our Zoom recorders and whatnot, we do prefer XLR mics. But no, there's a reason we prefer wired too. It's that it's very hard to interrupt a wired signal, whereas a Bluetooth signal can fail for all kinds of reasons. Anyway, yeah, I can try this. If you hold the mic for a second. Let me try the same thing now. Oh, this is getting tons of background noise. It might be hard to see anything, actually.
Oh, that's an omnidirectional mic.
Yeah, this is omnidirectional. You can probably see from the seats how much background noise it's getting. Oddly, the earbuds were not very omnidirectional. I think that the silicone tips actually did help with that. Anyway. So the difference is actually not nearly as big as it was with the other with the earbuds. This is where I can maybe understand if you show, it's just enough to show, I think. Basically, all 4 of the little trials that I did there, humming and ah, like M and ah, with the microphone near the nose and the mouth, they all sort of look the same. They're slightly different, and I guess if you took a ratio measurement, you might still get a difference. But like, actually, yeah, in this case, for this specific kind of response, the silicone-tipped earbuds might be better than a omnidirectional microphone. This goes to show you the importance of making test recordings. It should be pointed out, always make a test recording before you try doing something. You don't know how much background noise you're going to get, or how much cross-contamination from the nose or the mouth you're going to get in the signal. Turns out quite a lot of both here. So if you're doing something with an omnidirectional mic, you absolutely are going to need to put a baffle between them, I'd say. And it should be a pretty good one. But yeah. Anyway, your headphones might actually be better at this than this microphone, so definitely try it at home. Yeah, we could end 10 minutes early.
Well, I have an announcement to make.
There's an announcement to make.
Então, terminamos tarde ontem, o dia antes também, então eu acho que a gente pode terminar 10 minutos mais cedo hoje. Mas a gente queria convidar vocês para uma janta amanhã, depois da última aula. Se vocês pudessem, seria super bom terminar a semana com uma janta com todo mundo. E se vocês tiverem alguma recomendação para um restaurante, que seja não muito longe daqui, para o pessoal não ter que viajar bem longe, né, para chegar e para voltar, eu aceito sugestões. Vamos pensar, aí a gente volta para isso amanhã, certo?